The last thing we'll discuss together in this section is the derivative of the natural log, and this is probably the most interesting and the most important thing for me from this whole discussion in this section. So I would like you to focus on this a little bit more than other stuff here and just kind of know how to do this. And this is pretty simple, pretty straightforward stuff. It's pretty much saying what's the derivative of a function that has ln's. So the question is, if I have a function f that is ln of u, what would the derivative of that be? And the answer is, it's gonna be u prime divided by u. Okay, so in other terms, if I give you a function, let's say f of x equal to ln of 3x minus 2, and I say I would like the derivative of this, what would the f prime, the derivative, be? The answer is this. It's pretty much a fraction where you put the 3x minus 2 on the denominator, so it's gonna be a fraction, and then you write down 3x minus 2 on the denominator. Once you're finished, you take the derivative of 3x minus 2 and you put it on the numerator. So what's the derivative of 3x minus 2? Well, that's just 3. And that's it. You're finished now. So it's very straightforward. Derivatives of logs do not end up giving you logs. Derivative of logs turns out to be a fraction. Okay? So keep that in mind as you work through these next few problems. Okay? So let's take a look at the first one. It says y equal to 5 ln of x plus x squared. So first, I would like you to notice that there's a plus right here, which means we're going to be doing the left one by itself, the right one by itself. And it wants a derivative, so I'm going to start with dy over dx. This is the label of the derivative. There's a 5 being multiplied by ln of x, so the 5 gets ignored, and then ln of x. So what is the derivative of ln of x? The answer is this. First of all, it's going to be a fraction, and the x that is written next to the log, the argument basically, ends up in the denominator. So the x that's in the argument ends up in the denominator. Once you do that, ask yourself, what is the derivative of x? The answer is 1. Put it on the numerator. Then there's the plus sign that was earlier in the middle. We're going to write it down in the middle again, and then ask, what's the derivative of x squared this time? The derivative of x squared is just simply 2x. So what's the total? What's the solution? The solution is that dy over dx is 5 over x plus 2x. So that's pretty much the answer to this problem, the derivative. Okay? So pause the video for a second and see if you can do the next problem. It's pretty straightforward. It's just ln, plain old ln with x squared plus 3x minus 4. See if you can get the derivative of this. Okay, so if you got the answer already, that's great. If not, again, take a look right now. So I have ln of a lot of things. So the x squared plus 3x plus 4, those all represent what I'm calling in this section the argument. Okay, so they all represent the argument of the natural log. So the idea is this: if you want the derivative of the natural log of x squared plus 3x plus 4, you're going to end up with, first of all, some sort of a fraction, and the x squared plus 3x plus 4 is going to be in the denominator. Okay, so that's step number 1. Step number 2 is to take the derivative of x squared plus 3x plus 4 and write it in the numerator. So what's the derivative of x squared? That's 2x. Derivative for 3x is going to be 3. Derivative 4 is nothing. So 2x plus 3 over x squared plus 3x plus 4. And there's nothing more to do here. That means we are basically finished. Okay, again, very straightforward stuff. It's not that difficult. Okay, so again, remember 2 steps. Step 1 is to write the argument in the denominator, and step number 2 is to write the derivative of the argument in the numerator. And by doing that, you would be getting the derivative of that whole ln of so on and so forth. Okay, so that's how you get the derivative.